All right, good afternoon and good morning to everyone, depending on where you are. I want to welcome you to, I think, a very interesting session around using industrial metaverse, augmented reality, and artificial intelligence technologies at the factory floor. I have a really great group of panelists with me from across a diverse set of industry and academia. And so my goal here is to keep things interesting, keep our panelists on their feet along with the audience. So we'll try to interact as much as possible amongst ourselves, and we'll leave the opportunity for questions both throughout the session, but for the most part, we'll try to answer them here at the end of the panel. So the way that I want to start here is I want everyone to kind of give their perspective in terms of what AI, what industrial metaverse, what augmented reality technology means to each of you individually as a panelist. Because like I said, we're coming from academia, industry, different types of technologies, and I think it's good to level set that when you speak to this so that everyone has that perspective for every answer that you provide. And I'll start, with myself, both a quick introduction. I am Vice President of AI and Emerging Technologies at Prolifics, which is a mid-tier IT company. I'm also a chair of a non-for-profit called the AI Innovation Consortium, which is a collective group of industry academia. Some of the folks are actually here on the panel. And to me, when I speak to AI as it relates to the work that I'm doing, I'm talking about things like generative AI, like GPT, predominantly grounded in neural networks in ways in which algorithms learn structured in a similar way to the way that the human brain operates. It's kind of the state of the art of what statistics is about today. It's the state of the art in terms of what you're hearing in terms of the mainstream artificial intelligence work. And mixed reality and augmented reality, I'll let some of our other expert panelists kind of speak to that, because there's a general term for augmented reality that's kind of used holistically across different areas, but there are technical terms that also merit some definition. And so I look forward to this, and I'll start here with Hassan, since you're the first one in the top left side of my screen here, and let's go through the panel and get some introductions as well as what these technologies mean to you.
Sure. Hey, thanks. It's great to be here. My name is Hassan Poonawala. I'm an assistant professor in mechanical engineering at the University of Kentucky. So think bourbon and horses. My research is in machine autonomy, and these could be machines like robots and even simpler machines like CNC mills. So to me, AI means a lot of decision making. So whether you're planning actions, for example, in process control, or you're reacting to situations like robots that are picking up or repairing a part. And mixed reality the metaverse usually means simulating. So you have some big simulator of a process you're trying to control. You're getting information live from some real system, and you can sort of update that digital twin in real time. And so for me, the metaverse is kind of a decision augmentation tool.
Thank you, Hassan. So, Anand, I think you're next here in my windows. Maybe you can go ahead.
Yeah, hello everyone. Anand Krishnan. I manage ISP partnerships at Magic Leap. Magic Leap is a company that operates in the AR space, spatial computing area, as such. And our second generation device, Magic Leap 2, was released last year. For me, when it comes to mixed reality, AR, AI as such, I mean the convergence is almost inevitable, right? In the very basic kind of form, essentially AR and AI. For example, when you do gesture control and other things, AI is used. And on the other hand, AI is used extensively by our partners, our customers in kind of applications as such, be it conversational AI, and other areas when you want to map your environment, when you want to recognize objects, images, etc. My background as such, prior to Magic Leap, I've been in the AI space. I used to manage AI and cloud partnerships at IBM for several years in SAP. So, a good mix of both areas, I guess, and look forward to this conversation.
Thank you, Anand. JR, you're next.
Oh, thank you. Hello, everybody. My name is Jung-woo Ryu. I mean, Conrad just called me JR, so I also go by JR to make it easier. I'm the Chancellor and Chief Academic Officer here at Penn State Du Bois. Another title I hold is Professor of Information Sciences and Technology, so that's why AI and MR, those types of emerging technologies are near and dear to me. Just for your information, I just celebrated my first year anniversary as the chancellor at our campus in April of this year. So very excited. Regarding the question about what AI and mixed reality means to me, I really want to say that I mean, these types of things are not a panacea. Sorry to crush your dreams here. And I feel that these are just tools available to us. And it all really depends on how we use these tools. And sometimes these things turn out to be, a double-edged sword type of thing. So we really have to find the right application, right time, right place. I think that type of thing is really important. And I know, especially when it comes to something like artificial intelligence, asking the right question is the key to success. And we even have a new career path coming out, which is prompt engineering. So I think, yeah, it has a lot to do with how we use these types of technologies, and blind trust is really dangerous. And I also look at AI and mixed reality as an enabler. So, for example, during the pandemic, we ran into a lot of challenges, but at the same time, because we had these types of tools available to us, we were able to do, remote teaching and so on. So I feel that we could definitely go much farther with the technologies like, AI and MR, and we just have to find the right time, right place, and right applications to make our dreams come true. Thank you, Conrad.
Thank you, and congrats, JR. I saw that in your LinkedIn that you're celebrating your first year anniversary here as chancellor. I think I've known you for longer than I think I've known you, given the advancements you've had at Penn State. So next here in the introduction is Sean Riley. So go ahead, Sean, take it away.
Thanks, Conrad, and congratulations, JR, on your 1-year anniversary. That's a great milestone. I'm Sean. I'm Vice President Global Industry Solutions for Software AG, where I help to set go-to-market strategy across the various verticals that we support. I also specifically focus on the manufacturing and logistics verticals myself, as well as managing the global team. Prior to my 12 years with Software AG, I spent about a dozen years in various supply chain, manufacturing, and logistics roles. And I am a curriculum advisor for the graduate program at DeVault University in operations and supply chain management. So I'm looking forward to our conversation today. And what AI and mixed reality means to me is I like to focus first on a subsect of AI, specifically predictive analytics and machine learning, just because from my focus, that's really where it comes to. And that really uses predictive models to create improved outcomes for issues that are typically, they're either too large or they're too complex for people to make decisions on quickly and correctly in an ever consistent manner. For example, if you look at a shop floor and you want to understand what's driving product quality, as well as what's causing short machine stoppage and how can I go to improve that? Well, if there's a machine stop and it's a short stop, the operator might come over and hit a machine reset on it. And a minute later, it's back up and running. Did that help? Maybe, but that's the best action that can occur at that particular time as the first route, whereas applying an algorithm to that might recommend or might show a different path forward. from a mixed reality perspective, I really see that as a leveling technology. And the example I can give is you've got some great field technicians out that go to repair equipment, maintain equipment. And when you bring a new field technician on, they aren't necessarily as good as your seasoned technicians. They can't make as many repairs. They don't have as much experience, but that's where augmented reality can bring them up to speed and assist the knowledge that they do have, as well as bring in knowledge from other more seasoned technicians to enable them to resolve issues that are typically above their current technical standard. So that's where I really see those two technologies fitting, and with the end guise of delivering better outcomes. But like JR said, it is not a panacea for everything. There are definitely some roadblocks and hurdles in the way that I think we'll also discuss today. So thank you, Conrad.
Yeah, that's a good set of consolidated views of the technologies. You know, I'm going to steal from something I've heard a while ago, and basically it's this notion that these collective technologies elevate workers to the complexity of their tasks. And that's how I see AI connecting things like external data sources and analyzing them and presenting them in mixed reality, or using generative AI or GPT to support a connected worker with mixed reality technologies. It's a function of these technologies kind of in an aggregated way, bringing information together, bringing the relevant information together, and then presenting it and supporting this worker in their tasks. So then the next set of questions are going to focus around applications of these technologies and also barriers. So let's start with Anand, and I wanted to start with him because he's kind of the core technology vendor from a mixed reality perspective, and then we'll jump to Sean, and then we'll jump to the two folks from academia. And the question is share your applications of these technologies specific to your, maybe not to your industry, but to industries that you work with, right? So what are you seeing as the areas and the use cases that are adopting these technologies in the most kind of pervasive way? And speak to that a little bit, and then we can talk through that and maybe bounce some ideas around based on the use cases you present.
No, absolutely. The use cases are, there are multiple industries where, mixed reality, augmented reality is used. One that comes to mind and very related to, this discussion is the industrial manufacturing sector. A few different use cases are more common than the others. One is, around complex kind of assemblies, right? Being able to use, augmented reality to be able to guide people to assemble equipment, that is certainly a fairly strong use case. Training, like Sean mentioned, is another very, very strong use case. I almost see training as a continuum of sorts. There is upfront training, and then there is on-the-job training, there is reinforcement training. All of these are great use cases for augmented reality, based on the persona of the employee as such. The other use cases are around maintenance and repair, where essentially you're guiding a person through certain instructions to essentially fix an equipment. When you look at maintenance and repair, there are few KPIs that are more important than the others. For example, first-time fix rates, being able to, how quickly can they repair? Downtimes are critical. There's a direct impact of equipment downtime, and the bottom line of companies, how can you reduce that? And that is done by being able to effectively kind of identify a problem and then get it fixed, and then provide instructions to workers. So those are some use cases that are more common than the others when it comes to manufacturing industrial. The other industries, Conrad, are medical. For example, in healthcare, being able to do medical imaging, training of physicians. Those are some use cases. Devices are starting to get used in surgical, kind of areas as well, and that is another industry as such. The third is around architecture, engineering, and construction. There is a huge cost to kind of corrections that happen during construction of buildings, facilities, factories, and others. And being able to overlay models over certain areas where construction is going on and reducing the errors that happen during construction, managing it early also has a huge impact. There's a clear ROI there as well. So these are three industries that I can think of where AR can play a critical role to improve either the performance optimization, improve productivity, reduce cost.
Yeah, those are some great use case examples. Let me kind of connect the dots here for the audience between, I think, your perspective with respect to like the core hardware technologies and maybe Sean's perspective coming from software AG. So to me, and Sean, you can kind of course correct this connection as well. Devices like Edge AI, like connected worker systems, represent in part a next kind of wave of connected technologies, smart IoT devices, if you will. Some of the work that I've done, in fact, on the Cumulocity IoT platform that I'm sure Sean is very aware of, is connecting actual like hardware systems, like Edge AI systems, like connected worker platforms such as Magic Leap, to be able to manage them at a scale. Part of, I'm sure you've seen this, Ahmad, part of the key things to being able to grow these sort of technologies at a scale as it relates to connected worker tech, beyond the rudimentary pieces, like people have to like to use them and have a value behind them, is how do you manage them at a scale when you have 1,000 workers, right? And so there are key things needed, and in part those are platform technologies. Those are ways to manage remotely these types of hardwares, and maybe in some scenarios treat them as just essentially extensions of other IoT systems, collecting data to support and aggregate that data for the purpose of either bringing it back to the connected worker or bringing it to the top floor for analysis. So I think that's how I see the synergies here between Anna, your Magic Leap 2, for example, and Sean, the Cumulocity IoT platform, which is part of the Software AG suite. So Sean, maybe you can go through, like, again, similar applications of AI and industrial and metaverse technologies and speak from your lens. I think that'll give us a nice 360 view about these technologies and their application.
Yeah, I'd be happy to, Conrad. Specifically with the industrial segment, we see two key areas where artificial intelligence is used, especially in the manner that Conrad was talking about, from edge to, let's say, on-premises. On-premises being private cloud, public cloud, or old school data center in your office or something along those lines. But we'll just call it that for a simple continuum there. So Software AG has a great customer, and they make paint booths. And what's interesting about these paint booths is they're highly specialized for the automotive industry. They have a significant amount of robotics. They have drying elements. They have air filters. It's really a complex operation inside of this booth that a vehicle passes through. And to improve the use of their paint booth, which again is part of an assembly process, so it sits on the shop floor, but it's also a product of this customer, so that they have to make sure it operates efficiently, has lots of uptime, and they have some pretty strict quality parameters with their customers on the usage of those particular booths. But on the other hand, they're not there every day, so they have to be able to, first off, perform some very complex condition-based as well as predictive algorithms at the edge, but then leverage machine learning as well as formulation and deployment of those predictive algorithms in this central location. And to do that, they looked at, okay, we've got sensors on these robots. We want to understand what the robots are doing. And from a robot perspective, I want to look at distance to vehicle. I want to look at air pressure going through the robot. I want to look at distance to vehicle again. I want to look at particulates in the density of the paint in the robot as it's exiting the spray head. I want to look at robot vibration. I want to look at the rotation of the robot as well as arm extension. And I want to look at all of that in real time right away. Because one of the issues before they went on this journey was they could find a quality problem. It just took 3 cars worth of painting to find that quality issue. And that's kind of expensive from a repair perspective. So version 1 was find the issue, find it quickly, and now they can find that quality issue in less than 1 centimeter. So that's great. 1 centimeter, 1 square centimeter, I should say, of paint going onto a car, wonderful. Quality issue solved. But then there's the longer term issue of everything requires maintenance. And you can't have a machine running forever. They just degrade over time. Well, that's where the predictive algorithms come into play. So I want to predict what maintenance is needed when to ensure that my quality and operating parameters are as high as possible. So I'm taking streaming data, I'm running it through my complex event processor, that's also passing data to my predictive analytics that's operating on the edge, and that complex event processor is then monitoring what is coming out of my predictive analytics so that I can send an alert for maintenance. I can send an alarm for a component. I can send a trigger that I need to have a field technician go and service this particular piece of equipment. And the real key is that data then gets passed off in batch to where there are lots of smart data scientists taking it, working with machine learning algorithms to continually refine the predictive algorithms, and then without being present, update, replace those predictive algorithms on the edge. At the same time, they've got field technicians that, and this is where the mixed reality part comes into play, as well as a little bit of know-how, that are able to come in and create some really advanced, complex, and I can't get into details on this because this is a shop secret of theirs, but some very complex algorithms that look at multiple different operating parameters to determine what the optimal quality level is for that exact deployed paint booth. And while they were able to do that, again, the ever important first call repair rate went through the roof, because whenever somebody went out there, they knew what training that technician had to have. They needed to know what components they needed. They needed to know exactly how long it should take from an activity standpoint, and they could work it into their customer's production schedule. From a quality standpoint, they were then able to say, hey, guess what? We can paint an average size sedan with 1 liter of paint instead of the industry standard 2 to 2.5 liters of paint, because they've got complex event algorithms running on the edge in addition to the predictive algorithms. They then took that same type of premise and brought that to their R&D department, because the research and development department, their product management department, is also looking at this same data, which is where the digital twin part of the mixed reality comes into play. And they said, hey, wait a minute, we can redesign the filter on this booth. And more importantly, not only can we redesign it, but we can tell our technicians when that filter has to be changed, because paint filters, especially any air that gets expunged into the atmosphere, has to go to a rigorous filtering process. There's some not so great chemicals that are in automotive paint that people don't like to breathe, and the FDA really comes down hard on, as well as the EPA. So by doing that, they were able to now use 95% recycled air in their booths by being able to redesign the filter, as well as predict the remaining useful life of that filter for replacement. So it's an interesting use case of bringing together an industrial assembly process with a product, with everything that touches that from an AI as well as augmented reality perspective. That my hat's off to them. There are candidly few customers that were able to get their act together as quickly and in as advanced manner as this particular paint booth manufacturer was able to do.
So Sean, as you described that use case, and I don't know those details, just based on what you said here today, a lot of those discrete technologies that you mentioned, there was, I guess, a computer vision aspect to the process, right? In terms of the value that you're extracting features and analyzing for inspection. There was a predictive prescriptive analytics component to it. To me, as I hear this, and this is kind of the connection point, not just with academia, but one of the underlying themes that we wanted to convey towards the back end of this panel is that with the evolution of this technology, for example, computer vision. So traditional computer vision looked at kind of heuristic rules and try to determine if there's anomalies in different parts of the image it captured. AI computer vision, part of what it enables categorization of defects. So you're no longer looking at just this is an anomaly, but these are the categories of defects that I'm seeing. It also enables a lot of flexibility in terms of empowering companies. One is that traditional vision, and I've heard this time and again from people that run the production lines, you always have to constantly chase it based on the changes in the production line. So AI has certain flexibilities baked into its learning ability to be able to process new types of defects, right, and not have to reprogram itself. And it's also, from a cost perspective, an enabler for smaller organizations, smaller mid-sized manufacturers, right? Because these systems, whether it's the computer vision system or whether it's some core analytics platform that's been out in the market 30 years, with evolutions of open source AI, with evolutions of AI computer vision, you are now enabling, well, from the computer vision perspective, you can disassociate yourself from the hardware that cost you $100,000 because most of the processing is done within the AI software component. And similarly, with AI in terms of prescriptive analytics, there's so much out there now that's open source, or even if it's not open source, it's as a service, baked into a platform like Cumulosity, where you're getting out of box kind of a holistic toolkit that is very cost effective to get to the place where you can do vision quality inspection, do prescriptive analytics on your production line, and get some sort of business outcomes. So with that being said, I have two transition points. One is to the academic folks, because I think they bring a unique perspective, both because their efforts in part are research oriented, but also because part of their goals here is to work with the students and be able to enable the future workforce that is going to be using this tech. So I find that very interesting. And second is, I think our last missing panel is Dr. Satyam, who's the chief data scientist at Halliburton, who's able to somehow connect on the bridge. And although we can't go back in time and go through all the questions, I'd like him to just quickly introduce himself, and then for the following questions, I'll make sure to loop him in. So Dr. Satyam, would you be able to just introduce yourself quickly? I'm assuming you can go off of mute and just do that.
So I'm the technology fellow and the chief data scientist at Halliburton. I've been about 10 years, almost completing 10 years at Halliburton. Before that, I was in multiple industries like internet and others. And what I lead is a center of excellence for big data, data science, and digital. Built that from scratch for this industry, and I've built a couple of data science teams before coming to this industry. And basically look at all the emerging technologies, what it can help to transform a very complex industry. And that's in brief my introduction. As I'm also an academic professor at various places, both visiting adjunct in the areas of emerging technologies.
Okay, thank you for that. And we have a question here related to applications of these technologies for your industry. And so, without throwing the other professors out of time, Dr. Satyam, if you can just in 30 seconds maybe give us one of the most important, or if not the most important, application of this technology that you see within the oil field service industry. I think there are some folks listening from the oil field service, and I'm sure they'll be able to resonate with your point, and then maybe we can talk about barriers here in a minute after we get a chance to go through all the panelists.
Okay, perfect. So if you look at complex industry, just in general energy industry, right? If what is the most important thing is the fields that are like remote. And I think, as you can see, that applications of AR, VR, especially in fields, becomes a critical component for the transformation. Why? For example, one is if you can get a real-time insights as to what's happening in the field, and if you can combine the technologies of AR, VR. In fact, when you do that, you can actually call it what we use the term immersive reality. That means the person who's sitting in the headquarters can actually able to control or advise remotely on operating certain aspects of the field. Of course, while I say it in a single sentence, it looks very simple. It's not that simple, but at the same time, the evolution of AR, VR technology, the integration with the networks, that is the 5G and beyond, will actually enable these solutions to be really scaled up fast and actually reduce the downtime that happens in field operations. So that's one of the critical, I think, applications of this AR, VR. Besides, we can talk about training and simulation studies and things like that. But I think how do you transform that is what's very important.
Right. Okay. Perfect. Thank you. And we'll get back to talking to barriers here across the panel. So JR or Hassan, who wants to go next here? I don't have a particular order, so JR raised his hand first, so I guess he'll go next.
Can you hear me okay?
Yes, we can.
Okay. Yeah. You may wonder about what chancellors out there do, but one of my responsibilities is to listen to the community around our campus and really trying to figure out what their needs and try to help as much as possible. And after spending my first year, I now know workforce development is what our community really needs the most. Just to share a little bit of background, manufacturing is a leading industry in our town. We are located in the north central Pennsylvania region. One of the most prominent industries is powder metal industry. So we work with a lot of car companies, and our powder metal industry is probably, #1 in the world. So one of our major challenges is a labor shortage, and I don't think it's only our problem, but there are so many companies out there struggling to find the people. So as a solution, we've been thinking about introducing more automation to our companies in our area. And of course, automation doesn't just happen, and you really need to do a lot of workforce development who could really take advantage of automation technologies and so on. And that's when we thought we could definitely leverage things like artificial intelligence, things like mixed reality to train people who could be driving that automation movement in our industry. So currently we are collaborating with Conrad and his team to see if we can deliver our die setter training using AI and mixed reality. And I see a lot of promise there because, using the mixed reality technology, using the AI technology allows us to be very flexible. A lot of times I think what happens is the people who really need the training, they cannot just come to these training sessions because, basically it's at the cost of their shop time and they have to be there and producing things. So with these types of emerging technologies, AI and mixed reality, our hope is we make the training experience as seamless as possible, as flexible as possible. Maybe we can also turn it into something more asynchronous. That way, more people are able to participate in these types of workforce development activities. Thank you, Conrad.
Thanks, JR. And so I really enjoyed the way that you articulated how you want to align industry like this to the emerging technologies. I say that also because I've heard actually even this year, especially with some of the advancements in things like GPT, where in the questions that I get from audience, there's an undertone of uncertainty and fear in terms of what it will do to their jobs. Not everyone, but in part, right? And you know, I don't see it from that lens, and in part, I suppose to be objective. Maybe my answer is biased because I'm in AI, but the reality of what I believe to be the areas in which artificial intelligence can truly benefit is to augment existing things that people do and make them better, to elevate those workers, right? Like I mentioned, to the complexity of their tasks. A lot of the capabilities of GPT, a lot of the capabilities of AI computer vision, a lot of the capabilities of mixed reality technologies is all about aiding someone in things that humans just don't do well. Analyzing large volumes of text, analyzing large volumes of numbers and information, providing information overlaid to workers. So I think, you know, if we keep that in mind and we take your approach where we're looking to reinvent and align ourselves to future tech, because inevitably it will be there. I think, you know, we'll always stay ahead of the curve and we'll always be able to adjust to this new, call it industrial revolution, right? So Hassan, I know you've been sitting there patiently. Thank you for that. I know you have a lot to say, so maybe you can go ahead and speak to you know, your perspective on applications of these technologies within, you know, either yourself or within the University of Kentucky, and share us a little bit more about that.
Sure. So the problems I look at are real-time process control. So I have a Department of Energy project where we're just trying to reduce scrap rates. So we choose the cutting speeds, and traditionally people set one cutting speed and just, you know, take off material quickly to get a part done. But we said, well, maybe as the tool wears down, you got to slow down. And so what we can do is we create these models, these predictive models, and we have some sort of state of the machine. How much have you machined for using this tool? Do you have to slow down? Is it time to stop? Is it time to replace the machine? So these kinds of decisions where normally people are a little conservative, we can make more aggressive decisions by using models and predictions. And so there's a lot of work in, well, how do you model this process? At what different levels do you want to model it? We've gotten like a 200% improvement in productivity because you're willing to adjust dynamically your cutting speeds based on real-time information you can get from the machine. So a lot of the area is AI decision making to improve process productivity. What I was talking about was at the individual machine level, but you can think of it at multiple levels, whether manufacturing a single part, sending a part through different machines, or managing a fleet of machines to get the maximum throughput out of a factory. So all of these kinds of optimization problems, you need models and you need real-time information to make good decisions. And one of the rules, or one of the challenges we saw was, one, getting training data. And I think that's a place where augmented reality and mixed reality can really help. And so what I mean is, let's say you have somebody who's looking at a process and it looks good to them. They're experts, they know what a good process is or what a bad process is. And then they can say, okay, that looks like a defect. So for example, in wire arc, in additive manufacturing, welding processes, a lot of experts are able to listen and figure out whether there's a defect or not, which means instead of capturing, you know, tons and tons of data you don't even know what to do with, you have an expert who sort of chimes in and says, that was a defect. You would need to store that little piece of data for the last 2 or 3 seconds. What were you doing wrong? Capture that data, send it somewhere to get to update a model so that later an AI can help you make decisions. If you're welding and you make a mistake, you can locate the defect. You can figure out, well, do I have to just remove this little bit of metal and put a new, you know, add a little more metal there? Do I have to scrap the whole part? So this kind of real-time decision-making, data-driven decision-making, there's a lot of cool stuff on the research side. How do you make decisions? There's a lot of challenges on the data side of how do you collect this data, which is where I think mixed reality can really help. I want to do, before I finish, I would say one more barrier to adoption, other than you know, training and skills of people, is sort of the machines are outdated. And what I mean by that is they're not designed to get data out and get real-time decisions in, which is what I see in the projects that we execute. There's the Department of Energy project, the Department of Defense project. We're trying to do real-time process control, and then we find that the machines are just not ready for high-speed automated decision-making. And I would say that that's one barrier to adoption that needs to be addressed.
So, Anand, sorry, Hassan, you were mentioning listen. So, are you saying there's a certain acoustic signature that is made when the weld is done incorrectly? Like there's a noise, and the domain experts can pick up on that noise?
Yeah. So you're flowing material through something, and you can listen to the incorrect pressures of your welding apparatus. And so now we record audio signatures, and then we try and predict whether a defect has happened and where a defect has happened.
Yeah, right. So I find that particular use case interesting also because, part of what AI technology enables is tapping into insights that were previously left on the table because you couldn't consume them. Audio being one of those, like you looking at time series, acoustic signatures and then analyzing them, right? And doing that at a cost-effective way and being able to extract the signature that is intuitively picked up by the domain expert, but doing so through an artificial intelligence engine. So I find that both are very interesting use case, and one that I think speaks to this idea of the traditionally people that have used this sort of baseline technologies, I don't think they're aware of some of these evolutions. And I also think people that have just looked at using data to analyze things like quality or predictive or prescriptive analysis of their production line, they may have run into scenarios, and this maybe is a good way of transitioning into this concept of barriers. They may have run into scenarios where they're building this engine, and on the output, they are receiving predictive analytics that is not accurate. And part of that, or the majority of that, is actually because they are leaving data on the table that plays an important role in the actual outcomes of what they're trying to predict. Vibration, let's say, of or some sort of acoustic noise that is used, or let's say in a machining system, you're looking at telemetry data, but in reality, the core degradation is happening because a ball bearing is degrading, right? So the telemetry data, if you're not using very expensive hardware, or maybe there's no hardware at all available, is not something you're feeding into your simulation model to determine failure. And so if you're not feeding it, it's not part of the symptoms that is trying to predict the outcome, and then likely you'll have scenarios where you have false positives or false negatives. So I think part of the takeaway here from the perspective of barriers is you need to be tapping into these new channels of artificial intelligence to bring those into your prescriptive models.
Definitely.
So that being said, Anand, I don't know if you noticed, but I have a little product placement here on my right. It's your Magic Leap. Not intentional, it was sitting there, but I thought it'd be perfect to position myself around it. But you're the next person up, I think, in terms of the discussion, and I wanted to circle back on barriers of adoption. And I find, within your specific niche of hardware, some interesting things that I've heard coming from folks like Boeing and Lockheed, actually at AWE. And it wasn't your hardware specifically, but rather how to take connected worker technologies and bring them at a scale into large organizations. And there's a lot of, call them state-of-the-art barriers, which you guys are doing a great job of solving, like spatial computing and anchoring and all that stuff, which I'll let you speak to. But one of the ones that I think was solved, but traditionally there was difficulty in solving, is especially in organizations that require like strict security protocols to authenticate devices. The number one thing that was mentioned was just authentication and security for these devices when you bring them into this factory floor, and let's say that factory floor is building nuclear missiles, right? Like there's layers that need to be considered. So that being said, maybe we can start with you. Let's talk about the barriers, and let's not just leave those barriers on the table. Let's talk a little bit more about how to solve those barriers of adoption.
Yeah, certainly. I think the barriers for AR or mixed reality as such is no different from any other technology before this, right? For example, 10, 12 years back, mobile devices went through similar barriers, right? I mean, questions about usage and all of that. So when I look at barriers, certainly, Conrad, I think there is a knowledge gap in terms of how it can be used, right? I mean, so educating the market and stuff like that enough so that these solutions can go from innovation centers within an enterprise to broader line of businesses, right? I mean, identifying those use cases and then going from POC and pilots to scale deployment, right? I mean, there is a part there because there is a lot of experimentation that is going on when it comes to use cases, and then moving that over to specific business processes and all of that, right? I mean, so that is certainly an aspect. Security has a couple of different things. So you did mention, enterprise security as such. So that is again, a point of discussion as such. As these applications get more integrated with traditional enterprise applications, things like having to authenticate multiple times, one to an AR application, the other to an enterprise application, all of that, with convergence of technology, data silos being kind of removed, those will kind of be managed accordingly. There is a second aspect around safety, and those again will kind of as the market kind of matures, those will get kind of addressed as well. For example, certain kind of factories require a certain IP rating of devices and safety rating and things like that, and those will also get addressed, and there will be different devices across different segments. So in my view, there is a place for a device in the factory floor and certain kind of use cases. The safety aspect is certainly being addressed in parallel.
Those are, I think, the main ones that I had in mind as well. Sean, and maybe you had something in mind here for your barriers, but like I said, I like to throw my panelists off sometimes just to keep things creative. But you can also answer with your answers. I'm curious as it relates to bringing like application stacks like Cumulocity specifically. What are the barriers to being able to bring that type of platform to an organization? And because to me, like I see that Cumulocity to be in a light platform, to keep things agnostic, to be an essential component of a stack where you're ultimately delivering and managing, smart IoT and IoT sensors and aggregating them. But what do you run into within organizations as the barriers for that level of adoption? I'll call it, in fact, like the digital maturity, because to me, some of these organizations, they tend to start at the grassroots. So they'll start with some sort of siloed connected worker or edge AI application, and then they'll run into scenarios where now they're ready to scale. And if that happens, hopefully that's enough to justify the means to go and build a platform to manage everything at a scale. But sometimes that isn't. And sometimes you need to lead with, Cumulocity. If you're talking to CIO, for example, they want to be able to standardize the ability of these innovative technologies to be stood up. So maybe you can share both what you had in mind already in your answers, and also my ask on what are those barriers and how do you solve them?
Yeah, that makes sense. And candidly, I prepared 3 barriers for today's discussion. There are a lot of them, but there were 3 that I really focused on because they were the big 3. And 2 of them were already knocked out, which was really poor data quality and then the security concern. And just to reiterate, data quality. And I have a good friend of mine who builds these algorithms, and he's got a degree from Stanford and another degree from Cornell in math. So he's a little more knowledgeable on this than I do, but I trust him when he says to really build a good predictive algorithm, you need 6 months worth of historical data with faults. The first 3 months to build the algorithm, the second 3 months to test the algorithm against, and you should be predicting then all the faults. The problem is you have duplicate data mixed in, you have inconsistent data, you have different data formats, and the more you scale outside of that first small use case, the bigger the problem gets across the organization. So my observation has been that the biggest hurdle, especially to scale, is this poor data quality, because you spend a lot of money burning up really expensive data scientists' time normalizing the data. And candidly, with all the time and training that the data scientists have, it seems like there needs to be a better way. And there is, to just normalizing the data. Now there's also the argument there, you have a general data scientist, they don't understand all the business implications, fine. They're smart people, they can usually pick that up pretty quickly. But I have to chug through months and months of data to get rid of all the variation and inconsistencies out of it is, in my opinion, the number one drop. The second issue is really a process deficiency, and that is going about having a process of building and creating an AI program. It's easy to do it in a small environment that's static and controlled. Again, when you build it out to scale, having a robust process involved in terms of who's going to consistently be doing the building, where does the data come from, how does the data get there, how does the deployment work, and then how does the care and feeding, i.e. as manufacturing operations change, how do you control that drift and change your algorithms for that? That's really complex, and it deserves a little bit of thought. The third area, of course, is security. Everybody is hyper-focused about security, especially post pandemic, when you got to see the rise of malware attacks at an unprecedented rate. I know enough about IT security to be dangerous, but I will say this. In 2022, if you were a manufacturer, or I should say just a company, and you had a outward-facing API, then 95 of those companies got attacked through their APIs. However, if you look at all the breaches that occurred, it wasn't through the traditional, I'm watching a 1980s movie, and I'll pick on Matthew Broderick hacking into the Department of Defense with Whopper there. They're usually much simpler phishing attacks, and the exposed security is the human. It's me, it's you. That's where the security breaches most of the time end up coming from. I'm not saying that companies shouldn't be concerned about security, especially when deploying AI, because it needs so much correct data. But if you look at where the breaches come from, it's not from a hole in the firewall. It's typically somebody opening the firewall for them.
Hey, Sean, we have 5 minutes, and I think I gave you loaded material here to answer, so I apologize for that. Speaking to security, I'll give you one quick story that I've had a pleasure to work with, and it's around federated learning with AI. And although this is not the example that we actually worked around, this is a nice equivalent of that example. So imagine if you're doing federated learning, for those of you that don't know, it's basically multiple different independent parties training an AI model for purpose, and you can assume those parties, they could be like state organizations, they could be different companies across the world, they could be different divisions within the same organization. And the idea of federated learning is that when you train the AI model, you don't have to share data, you just share the weighted averages of the results of your trained data. But what you can do with federated learning is pretty interesting, is you can train the model and you can introduce these malicious things into the model for prediction. So for example, and this was actually a study, I don't know, I can't recall who performed this particular study, but if you have stop signs and you're training an AI vision model to detect a stop sign, you can introduce stop signs with little diamonds in them and tell the model that that's not actually a stop sign. And the reality is that no one has access to the data set, so all you're seeing is the weighted averages of the model being updated. So at face value, it's very difficult to detect. And the theory behind that is you deploy this model, and then let's say some malicious actor decides, well, now is the time to start drawing diamonds on the stop signs, and all the automated cars in 2034 start running stop signs, right? That maybe practically won't happen, but federated learning is at our doorstep. So there are new challenges to security as it relates to building, well, these models, they will need to be built in a way where they're robust, they're precise and accurate, so they can be fully autonomous. And we'll get there, but we'll get there with a lot of security challenges. So that's just food for thought, and there's obviously ways to solve those. I want to get a chance for Dr. Satyam to talk a little bit about barriers, and then we'll jump to JR and Hassan quickly, and then I'll let the panelists give our one takeaways, which is the last thing I'll have on the table since we're running close to the end here.
All right. So, some of the basics of barriers have been discussed here: data quality, etc., the security, poor data, time spent on data, etc. So I'm not going to talk about those. Those are important. But one of the most important things that I have really seen over the last decade or so is actually the leadership approach to these problems. Right. One of the big challenges that people think that something like AI or algorithms are a magical thing, and they can produce results in shorter time than they can do business intelligence. So there is a misunderstanding about what AI can do or how is it need to be implemented. And when it comes to integrating the data from AR, VR, one of the things that is usually missed is actually trying to understand the full scope of the challenge. For example, I think one of our speakers before me was talking about looking at equipment or machines that are having failures, right, for various reasons. But if you really want to understand what's happening in the field, one has to really understand the full ecosystem. This is why the term that I use is called, you need to build digital twin of digital twins. And when you do that, then you actually integrate the solutions that are, or the applications of AR, VR for each of these micro digital twins, and then integrate them for the whole process. And then you actually look at the actual value that is being created, that becomes significant. So one of the practices that people don't do is they say, oh, this equipment is failing, let's go and build something, or build a simulation study or learning for a little piece of the puzzle. And then in the process, they miss out some of the important components of that full puzzle. And that has been a real problem, because you don't get the full picture. Then you think, oh, this is not working. And hence the leadership will say, oh, this thing doesn't work, so let's scrap the project. And this is why you see statistics saying data-related projects fail, or 8x%, 68, 70, depending on who you are talking to, they fail. Actually, in my view, they don't fail. The question is they only produce little bit of value, but we as leaders did not find a way to really scale that value. And that is, I think, one of the biggest barrier of adoption for these technologies, because this requires investment, and there's investment of course, money, but at the same time, investment of time and investment of talent, of what I call integrated people, right? It's not about just bringing a data scientist or bringing a AR, VR expert or bringing a domain. You need to bring all those people together. Building that multidisciplinary team is very hard for many organizations. But if you do that, I guarantee that none of the projects will actually fail.
Yeah, I mean, I would totally agree with that. And I've seen, specifically in oil and gas sector, with respect to some of the leading edge technologies, it kind of throws the traditional bucket of just data science, not so much out the door, but it kind of disrupts this idea that data scientists alone can be able to work with artificial intelligence and be able to develop and deploy against requirements. So I do agree that multidisciplinary teams are critical. We're over time, but we started 2 minutes late, and I want to give Hassan and JR some last words. And in fact, the last question to everyone is one takeaway. But Hassan, I'll let you lead with the takeaway, and you'll get a little extra time since you've been patiently sitting here. And then JR, go ahead after that, and then we can all give a 15-second takeaway for the audience here.
So about barriers, I think not just multidisciplinary teams, we need multidisciplinary individuals. And to get there, I would say my big takeaway is to support upskilling programs in both AI and manufacturing at the same time, so that you can have people who have both a dual expertise. And I think that'll be important to advancing smart manufacturing and all of these technologies. So
absolutely,
again,
thank you.
Support upskilling.
Right. Thank you. Yeah, thank you. Yeah, I think one of the biggest barriers, I mean, it's been, at least to us, the lack of customizable software solutions. And without the expertise, it's difficult always to start from scratch. So it would be wonderful to have some customizable software solutions for mixed realities or artificial intelligence out there. And then one takeaway for you would be, this is what I tell to everybody, but if you need help, always don't hesitate to ask for help. There are always people out there who could help you, and never give up.
Sean and Anand, what's your one takeaway here?
My one takeaway, it's going to be a little bit of shock to everybody, but when you're implementing AI or mixed reality, make sure the people working on the first project don't love the technology more than the outcome. But make sure it's not someone that says, oh, this is my hobby, I love this, I'm going to do it, because guess what? They're going to make it happen because they love it. And then when you go to use case 2, or you go to plant 2, or you get a project number 2, there's going to be all sorts of problems because you're going to have people there that love the outcome, but not the technology. So that's my key takeaway for this is, if nothing else, make sure you always have people that don't love the technology more than the outcomes.
That's a good one. Anand?
Yeah, for me, people have been talking about mixed reality AR for many years now, and my takeaway here is that now is the time to try out. Now is the time to adopt, mixed reality, augmented reality, because it can solve real business problems, especially with the convergence of technology, the whole digital thread concept that connects, the value chain or the applications from left to right, all the way from CAD to IoT to AR and AI. Where you can really kind of solve critical business problems, and mixed reality can be the endpoint to a lot of these things.
Dr. Satyam?
Yeah, I think I heard somebody said upskilling multidisciplinary people. That is certainly important. I can tell you that since we have been doing that for the last 9 years in the industry, training geophysicists, drillers, etc. in this area, that has certainly been very valuable. And I think one should really think about bringing that from the academic point of view. I did actually help the University of Houston people to build integrated coursework into digital and offshore drilling, etc. So I think academics, if they can actually bring in these examples. The other one is that industry and academics has to really work on giving out real world projects. Large portion of students work on synthetic data or what is called toy data. That doesn't really help them to see what is really the problem, especially in energy sector. There is so much data from the past 30, 40, 50, 60 years, which may or may not be of good quality, but that is the data that comes from real world. If that can be actually shared or accessed in a way that students can actually build projects on it and understand the real workflows, that will really change the next generation workforce.
Thank you. So I have one takeaway and one call to action before we conclude. My takeaway is to use the technology, to use it hands-on. I think as it relates to things like the Magic Leap 2 or some other mixed reality hardware device, it's one thing to see a video, it's another thing to experience the actual use of the technology, even using things like GPT, where you're actually using it for purpose. It's an extraordinarily powerful tool, and it's not a matter of just hearing what you heard on the media or reading an article. If you use the technology, it will enable you to align it to, as an end user, to use cases that are relevant to you, and will give you kind of a hands-on understanding and confidence of what it can accomplish. So I urge you guys all to do that. As a call to action, most of the folks here are actually working with us at the MXD USA facility, which is a facility sponsored by the Department of Defense out of Chicago. we have a really interesting setup there, connecting an industrial FANUC robot with different computer vision, edge AI, quality inspection systems, all aggregated through the Software AG Cumulocity platform. And it's a sandbox for industry, both in the oil and gas and in the manufacturing space, to be able to see these technologies kind of work together in a very practical, hands-on way, but also to work with us on building something specific to them. So the call to action is, after this webinar, you'll get an email giving you the opportunity to engage us in a more detailed discussion, from which hopefully you can collaborate with us on something more tangible. And in between then and now, use the technology. I'd like to thank all my panelists today for attending these. I've had some great experiences with each and every one of you. So thank you for your contribution, and thank you to the audience for listening to us, and for the AV team in Erica and Pamela for supporting the webinar. So thank you, everybody. And for those of you interested in distributing this, the recording will be made available to you for redistribution at some point in the near future. Thank you all.